In this video, we'll be discussing section 2.1 from chapter 2 of P3, and this in this section we'll be specifically discussing the modulus function. Okay, so while this chapter is the official introduction of the modulus function, we did actually deal with modulus functions when we were discussing let's say integration with integration of 1 by x and the binomial expansion in P4. Okay, so over here for the official introduction of the modulus function is basically the magnitude of a particular number. Okay, so if you have number 3, in that is the modulus symbol, which is represented by this straight lines around the number, will give you the magnitude of the number. Okay, the non-negative numerical value of the number. Okay, so 3 modulus is going to be equal to 3. Okay, and if you have minus 3 the whole modulus, we just remove the negative sign. Okay, it's going to be 3 as well. Okay, so the modulus function, also called the absolute value function. Okay, the modulus function, the absolute value function, gives us the non-negative value of the number or the function. Okay, so if you have a function, let's say fx, okay, if you have a function fx, okay, which let's say that it goes both above and below the x-axis. Okay, in that case, wherever fx is positive, so if fx is positive, in that case this fx modulus is going to be the same number. There's nothing changed if fx is positive. But if fx is negative, okay, by negative we mean that if it is less than 0, in that case the sign of fx changes for the modulus. Okay, so if fx is negative, in that case fx the whole modulus is going to be minus fx, because the sign is going to change. Okay, so if fx is negative, the final answer for the modulus should be positive. Okay, so the modulus function is always positive. Modulus function is always positive or always greater than or equal to 0. Okay, 0 modulus is 0. Okay, because 0 is 0 and minus 0 is also 0, so 0 modulus is 0 definitely. Okay, so on your calculator you can use the absolute value function over here. So let's consider the absolute value function. Okay, and if you you get the straight lines. Okay, and 8 modulus is going to be 8, minus 8 the whole modulus is going to be still 8. Okay, so we are considering the non-negative values over here. So if we consider an example, if you say that you want to calculate 2 minus 36 by 5, okay, the whole modulus. Okay, 2 minus 36 by 5 the whole modulus. First, okay, you cannot apply the modulus to each symbol separately. Okay, simplify the expression and then apply the modulus to the entire thing. Okay, this is not equal to, the modulus function is not a linear function, such that you cannot write this as this and then apply the modulus function separately. This is definitely not right. You need to simplify the expression in the bracket inside the function. So over here, 2 minus 36 by 5, if you use your calculator, you'll get minus 26 by 5. And then when you apply the modulus, it becomes 26 by 5. Okay, so simplify the function inside the bracket and then apply the modulus symbol. Okay, now let's consider example 2 on page 11. Okay, and in example 2 on page 11, they have given us the function fx is equal to 2x minus 3 the whole modulus plus 1. Okay, the first part of the question is to find f of 5. Okay, so if you want to find f of 5, in that case substitute 5, we get 2 times 5 is 10, minus 3 7. Okay, 7 modulus plus 1, 7 modulus is 7, so that is 7 plus 1, and that is equal to 8. Okay, the next question is f of minus 2. Okay, substitute minus 2 into the expression, you get minus 4 minus 3, that is minus 7 the whole modulus plus 1. Minus 7 the whole modulus is equal to 7, you remove the negative sign, plus 1 is equal to 8. Okay, and then we have f of 1. Okay, so substitute 1 again into the equation, into the function. We get 2 times 1 is 2, minus 3 is minus 1. So minus 1 the whole modulus plus 1 is equal to 1 plus 1, which is equal to 2. Okay, so again, trying to evaluate the modulus function, you first insert the simplify the expression in the modulus and then take the modulus of the function. Okay, now let's consider this graph over here, fx. Okay, this is the graph of y equals fx. If we want to draw the graph of y equals fx the whole modulus, okay, if you want to draw the graph of y equals fx the whole modulus, in that case, notice that whatever is positive, those remain positive. Okay, whatever is above the x-axis remains above the x-axis. Fx modulus does not change anything for the positive values, but whatever is negative, okay, those values, the modulus symbol is going to make them positive. In other words, whatever is below the x-axis, those portions will reflect across the y-axis, across the x-axis. So, and this portion will become such, this portion will become such, and this portion will become such. Okay, so your fx modulus graph, the overall graph is always going to be above the x-axis. Okay, so if we take the function, it is above the x-axis. Okay, whatever is below goes above the x-axis. Okay, on the other hand, we have, let's say that if we draw the same graph over here, and you're going to draw y equals f of x modulus. Okay, y of f of x modulus. This is the bit more like over here. The only thing we did was, because I take a modulus function, whatever is below goes above. Okay, over here this is a bit more tricky to understand. Okay, notice that if we have f of 2, okay, let's say that let's draw the original graph again. So we have, okay, so let's draw the original graph again. Now let's talk about, let's say that this is at 1, and this is at 2, this is at 3, this is at 4, this is at 5, let's say this is at 5, this is at 6. Okay, and so if f of 1 is equal to this much, what happens to f of 1? Okay, so f of 1 modulus is equal to f of 1. There is no change. F of 2 modulus is equal to f of 2. Okay, 1 modulus is 1, 2 modulus is 2. Okay, f of 3 modulus, okay, is equal to f of 3. Okay, so if x is positive, so let's say that f of 100 modulus you take, okay, this is equal to f of 100. Okay, so none of these values are changing. Okay, the modulus symbol is changing nothing if x is positive. Okay, so the right hand side of the graph remains the same. Okay, what happens on the left hand side though? Let's say that if you want to find f of minus 1, okay, f of minus 1 the whole modulus, that is going to become now f of 1. F of minus 2 the whole modulus, that is going to become f of 2. F of minus 3 the whole modulus, that is going to become f of 3. F of minus 100 the whole modulus, f of minus 100 modulus is going to become f of 100. So in other words, for the positive values of x, the modulus symbol inside did not make any changes. Okay, whatever is below remains below, whatever is above remains above. Okay, there is no flipping over here taking place on the right hand side, but whatever is in the left hand side, okay, those are all now becoming equal to values, corresponding values on the right hand side. So at minus 1 you'll have the value for 1, okay, because this is f1, this is f1. At minus 2 you'll have f2, f2. At minus 3 you'll have f3, f3. At minus 100 you have f100, f100. In other words, you have to reflect this graph in the y-axis, okay, and you get this. Okay, so this is how the graph gets transformed when you have this modulus functions. Okay, so again in summary, if you have y equals, let's say hx the whole modulus. Okay, so the whole modulus means that this function is always going to give you positive values. The whole modulus means that this function is always going to give you positive values. So this graph, you need to transfer all negative portions below the x-axis to above the y-axis. So such a graph is going to look like, let's say, okay, this graph is never going to go below the x-axis. Okay, on the other hand, if you have y equals h of x modulus, okay, this graph, you'll have the right hand side and the left hand side similar to each other. In other words, you'll have a symmetry along the y-axis. Okay, and thus in this case you'll have, okay, let's say that our function is, in that case over here on this side you'll have, okay, so you have symmetry along the y-axis. Okay, because all negative values are now, because the modulus function, let's say f of minus 10, if you have x equals minus 10, it is going to give f of 10 rather than f of minus 10 because of the modulus symbol over here. Now we'll be discussing these graphs in more details in one of our later sections. For the time being, let's continue discussing the modulus function and trying to solve equations. The first example we're going to do is to try to draw the graph of y equals 2x minus 1, the whole modulus. Okay, so to draw the graph of y equals 2x minus 1, the whole modulus, first draw the graph of 2x minus 1. So 2x minus 1, if you draw the graph, notice it is a straight line with gradient 2, y-intercept minus 1, so we have minus 1. Okay, we have minus 1, we have got gradient 2 and y-intercept 1, so it is a steep graph, and the x-intercept is half. Okay, so the x-intercept is half. Okay, and this graph goes to minus 1. This is 2x minus 1. To do the modulus symbol, okay, the entire function we're taking the modulus, therefore whatever is below the x-axis gets flipped. So this portion gets flipped and you get this V-shaped curve. Minus 1 becomes 1. Okay, half is still at half. Okay, this point is still at half. Okay, in other words, notice that because you take a modulus symbol, this function is always positive. So since this function is always positive, okay, this entire graph is always going to be above the x-axis. Okay, now let's consider another example. In this example, we are asked to solve the equation. Okay, solve the equation 3x minus 5, the whole modulus, is equal to 2 minus half x. 3x minus 5, the whole modulus, is equal to 2 minus half x. Okay, so whenever you have modulus functions, it's always a good idea to sketch the curve, to sketch the graph. Because often the modulus function, the symbols and all that stuff can make it difficult and to imagine, and there might definitely it's possible to make errors with the modulus symbol. So let's try to draw a graph for this function. We are going to solve this equation. So we need to draw two graphs. We need to draw y equals 3x minus 5, the whole modulus, and y equals 2 minus half x. So let's draw the graph. The first graph we're going to draw is 3x minus 5. 3x minus 5 is going to pass through minus 5. Okay, it has got y-intercept minus 5, and it is a steep graph with gradient 3. It passes through the point 5, 3, and this is 3x minus 5. But this is not the graph in question. The graph in question is 3x minus 5, the whole modulus. Therefore, whatever is below the x-axis gets flipped because all negative values are becoming positive. Therefore, we have this graph now, a V-shaped graph. Okay, that passes through 5. Okay, the minus 5 becomes 5, and it's still passing through 5 by 3. So this is our graph for 3x minus 5 the whole modulus. Next we have is 2 minus half x. So this graph, notice it has got gradient minus half and it has got y-intercept 2. So 2 is somewhere here. Okay, 2 is somewhere here, and it is going to have gradient minus half, so it is a downward it is slanting downwards. So you'll have something of this kind. Okay, minus half, and it is not steep because of the, notice that the gradient is not that big value, it is minus half, so it is a very gentle slope graph. Let's redraw the diagram and get just before you continue drawing the graph, this 2 minus half x is going to pass the x-axis at 4. Okay, so it is after 5 by 3, so we have some point over here. Okay, 4, we have this point over here 5 by 3, we have this point over here 5, and we have this point over here 2. So this is your this is our y equals 3x minus 5, the whole modulus graph, and this is y equals 2 minus half x. Okay, so 2 minus half x is a regular graph having intercept 2, y-intercept 2, and gradient minus half. Okay, 3x minus 5, the whole modulus is going to be 3x minus 5, and then the negative part you flip across the x-axis. Okay, now to solve this equation, we need to find these 2 points. Notice that there are 2 solutions to this equation. Okay, and the 2 intersection points means there are 2 solutions. The first part, okay, let's talk about this point here. Over here we have this line and this line intersecting. Okay, so this line is definitely 2 minus half x, so that one is the same, doesn't change. And then this line is going to be 3x minus 5. Okay, notice that this is 3x minus 5. Okay, we are removing the modulus symbol here. For this left point, the 2 minus half x is the same. Okay, for the left point, 2 minus half x is the same, and this line which you see over here, it is not 3x minus 5, it is minus of 3x minus 5. Notice, because it is negative, it was the negative portion of the graph. Okay, the negative portion got flipped across the x-axis, so this is actually minus of 3x minus 5. Okay, it is the negative of the negative value to give a positive value. Okay, so now we can solve both these equations. Okay, whenever you have the modulus symbol, 3x minus 5 the whole modulus, you're going to have 3x minus 5 to solve one equation, and you're going to have minus of 3x minus 5 to solve the second equation. From this equation you get 7 by 2x is equal to 7, and x is equal to 1, x is equal to 2. Okay, and from this equation you get minus 5 by 2x minus 3, and therefore x is equal to 6 by 5, which is 1.2. Okay, so it does make sense. Notice that you have 1.2 which is less than 5 by 3. Okay, 1.2 is less than 5 by 3, it is to the left of 5 by 3, 1.2 is here. Okay, if we try to zoom this in that case, notice we have something of this kind. So we have 5 by 3, and this is 1.2, which makes sense because 1.2 is less than 5 by 3, and this point over here is going to be 2, and that also makes sense because 2 is greater than 5 by 3. 5 by 3 is approximately 1.67. Okay, so 1.3 is less than 1.67, that is the left point. Okay, this is your left point, and this is your right point. Okay, where x is equal to 2. Okay, now do you need to find the y values? The question, we use the graph, okay, to help us find the solutions. Okay, the question did not ask for y, the question did not have any y, and therefore we just need the x values. So the x is equal to 1.2 and x is equal to 2, and that's all for our answer. Now Let's consider this next example. The next example is example 6. This was example 5. This was example 5. This was example 5. Now, this was example 5. Okay, so we have solved this equation again. We have the positive 3x minus 5 is equal to 2 minus half x, and we have the negative 3x minus 5 is equal to 2 minus half x. Now, let's consider example 6. In example 6, we are asked to solve the inequality 5x minus 1 the whole modulus is greater than 3x. 5x minus 1 the whole modulus is greater than 3x. Okay, first step, let's draw a graph. Okay, to help us visualize what exactly is solving. First step, let's draw a graph. We're going to draw y equals 5x minus 1. (5x minus 1) is going to pass through minus 1, and let's say minus 1, and it's going to have a steep gradient of 5. Okay, so it is going to have a steep gradient of 5 with this value is 1 by 5. Okay, so you have minus 1 as the y-intercept, 1 by 5 as the x-intercept, and this graph has got gradient 5. Okay, now we need to draw my 5x minus 1 the whole modulus. So whatever is below gets flipped, and we get minus 1 becomes 1, positive 1, and this is the graph of y equals 5x minus 1 the whole modulus. Next we have is 3x. Okay, so 3x has got gradient 3, y-intercept is 0. Okay, because it is 3x plus 0, we can write it as 3x plus 0, 3x minus 0 doesn't make a difference. It is passing through the y origin. Now, notice that it has got gradient 3. Gradient 3 is less than gradient 5, therefore it is going to be less steep than this graph. Okay, so you have y equals 5x minus 1 the whole modulus, and you have got y equals 3x. Okay, again repeating what we did, we drew first 5x minus 1, and then we flipped whatever was below to above the x-axis, and then we drew y equals 3x. Okay, 3x has got lower gradient than the 5x minus 1 graph. Okay, so therefore this is a bit gentler. It is a bit gentler in its slope. Okay, now we need to solve 5x minus 1 the whole modulus is greater than 3x. This is the equation you need to solve. Okay, 5x minus 1 the whole modulus is greater than 3x means that the modulus function is greater than the other regular function. So the modulus function is this function. It needs to be above this line. Okay, so we have this portion. This is the portion that you need. Okay, this is the portion that you need, and also this is the portion you need. Okay, because over here also the modulus is above the 3x line. Okay, over here the modulus is above the 3x line. Over here also the modulus is above the 3x line. In this portion the modulus is below the 3x line. Okay, now we got what you need to find. We have understood what you need to find. Now let's continue finding the answer. You need to find this point and this point. Okay, at this point 5x minus 1 is equal to 3x. Okay, notice it is the regular 5x minus 1 graph that is equal to 3x. At this point, okay, the left point, the graph got flipped, therefore that is going to be minus 5x minus 1 is equal to 3x. Okay, so where the graph did not get flipped, it is 5x minus 1, simply remove the modulus. Where it got flipped, it is minus of 5x minus 1. Okay, put the minus symbol to indicate that the graph got flipped. Okay, over there. So now you can solve both of these equations. Okay, we get from the first equation we get 2x is equal to 1, x is equal to half. From the second equation we get minus 8x equals 1, sorry, minus 2x minus 8x equals 1 equals minus 1, sorry, minus 8x equals minus 1. If try to do it in steps if you are not able to do the entire thing in one step. Okay, so minus 8x equals minus 1 and x is equal to 1 by 8. Do these points make sense? Okay, so you have x equals 1 by 8, x equals 1 by 8 is over here, and x equals 1 by 2 is over here. Okay, this is the positive portion of the modulus function, so that's 1 by 2, the right point. This is the left point where the graph got flipped, so that is 1 by 8 over here. Okay, do these points make sense? Notice that 1 by 8 is less than 1 by 5, so this actually does make sense. 1 by 2 is greater than 1 by 5, so that also makes sense. All the values are positive. The graphs are all intersecting in the first quadrant. In the first quadrant everything is positive, so all the x values are positive. It does make sense. Now the final answer is going to be, we need two portions, one here and one here. So the final answer is going to be x is greater than half. Okay, the right value is half, or x is less than 1 by 8. Okay, x is greater than half or x is less than 1 by 8. That's the answer to this question. Now let's consider another example. In this example, we'll be doing question number 10 from exercise 2a. Question number 10 from exercise 2a. Question number 10 from exercise 2a on page 15. Okay, and the question says that a student is attempting to solve 3x plus 4 the whole modulus is equal to x. Okay, 3x plus 4 the whole modulus is equal to x, and the student writes, okay, so the work that the student has done, notice that we have modulus, so when 3x plus 4 is positive, we can write 3x plus 4 is equal to x. When 3x plus 4 is negative, we can write minus of 3x plus 4 is equal to x. Okay, so 3x plus 4, we have the positive 3x plus 4, we have the negative 3x plus 4, okay, and that is equal to x. So now if you try to solve this equation, you will get 2x is equal to minus 4, x is equal to minus 2. Okay, so this is for the positive side, okay, positive of 3x plus 4. If you solve this equation, you get minus 3x minus 4 is equal to x, minus 4x is equal to 4, x is equal to minus 1. Okay, so this is what the student received in the work that the student does. Okay, and the question says to explain the error that we have in this particular working. Okay, so we did solve x equals minus 2, we did solve x equals minus 1. Okay, the error over here might not be that apparent, so we can try to draw a graph. But notice another thing over here. Okay, without drawing the graph, notice that we have 3x plus 4 the whole modulus is equal to x. 3x plus 4 the whole modulus is equal to x. This side, 3x plus 4 the whole modulus is always going to be positive. Okay, so 3x plus 4 the whole modulus, the left hand side is always going to be positive. So if the left hand side is always going to be positive, then the solution needs to be such that the right hand side is always also positive. Over here we got negative solutions, and thus these are not acceptable solutions. In other words, you do not have any solutions. Okay, so this solution is not acceptable, this solution is not acceptable, because the modulus function can never give you a negative number. Okay, x cannot be negative. Okay, both left hand side and right hand side need to be positive. Over here we got negative answers, both the answers are not acceptable. In other words, we don't have any solution. Now in an examination, it might be a bit more troublesome to try to get to this depth. So in that case, let's try to draw a graph again. Okay, as I said, and drawing a graph for modulus function is always helpful. Okay, if you try to draw a graph, in that case, let's first draw 3x plus 4. 3x plus 4 has y-intercept 4, and it has got gradient 3. So we do have a steep graph over here. Okay, we have a steep graph over here. Now this portion over here, this is at point minus 4 by 3. Okay, and this portion gets flipped because of the modulus symbol, and we get this. Okay, let's draw the second graph over here, y equals x. Y equals x is going to be a less steep graph, but still a positive gradient graph. We have this graph over here. Okay, it is less steep than the 3x graph. Notice that you don't have any points of intersection between the two graphs. Okay, therefore there are no solutions. Okay, we don't have any solutions to this graph. Okay, let's notice another thing, whether the answers in the previous cases when you were trying to solve, in the previous cases we tried to compare the answer to the vertex. Okay, this vertex over here, the point over here, we try to compare the answers and it made sense. Over here the answers should not make sense. Let's see. The first answer over here, -2. This is the solution of the positive graph with x. That means this graph with x. This graph with x. -2 is less than -4/3. The answer that if these two did actually intersect with each other, the answer should have been greater than -4/3. It should be somewhere here. Okay, but you're getting -2 is less than -4/3, and therefore this does not make sense. Okay, and over here the negative portion is this portion. This one should have given us an answer that is less than -4/3, but you have -1, and -1 is greater than -4/3, so this also does not make sense. Okay, overall we have no solutions. Okay, so again, in general, if you do have a modulus function and you're asked to solve the equation, it's always better to try to draw a graph, okay, to prevent any such situations where you get some answers which actually are not correct. Okay, let's consider another question. In this question we're going to solve question number 12 from the same exercise, and we have to solve the inequality 2x plus 9 the whole modulus is less than 14 minus x. 2x plus 9 the whole modulus is less than 14 minus x. 2x plus 9 the whole modulus is less than 14 minus x. Okay, so again, let's start with drawing a graph. The first graph we're going to draw is 2x plus 9. This graph passes through the point 9, and it is a graph with a gradient 2. Okay, it crosses some point over here. We do have the 2x plus 9 goes downwards, but because it's modulus, this graph gets flipped. Okay, this point over here is going to be -9/2. Okay, this is when the entire function is 0. So if you equate this to 0, you get -9/2. So this is your 2x plus 9 graph. Now the next thing is we have 14 minus x. This graph passes through the point 14, and it has got gradient -1. Therefore it is going to be less steep than this graph. Okay, so it is going to be a gentle graph. The point over here is going to be 14. Okay, you can calculate that. Okay, the gradient again, y-intercept is 14, gradient is -1. Since this graph is less steep than this graph will cross this graph at some point. So you can redraw the graph to make it look better. Okay, so because this graph is less steep than this graph, okay, this graph has got gradient 2 and -2. This graph has got gradient -1. Therefore it is going to cross at some point. Okay, so we have 2 points of intersection, and the question is asking us to find 2x plus 9 the whole modulus is less than 14 minus x. In other words, the modulus function is less than the straight line. So the straight line is this, and the modulus function is to be less than that. So it is this portion over here. Okay, this is the portion. Okay, this is the portion where, okay, this is the portion where your modulus function is less than the straight line function. Now let's find the points of intersection. The first point of intersection is this one. Over here we are going to use 2x plus 9 is equal to 14 minus x. Solve it. You get 3x is equal to 5, x is equal to 5/3. Okay. Now for the left point over here, this graph was flipped, so therefore for that one you have minus of 2x plus 9 is equal to 14 minus x. solve the equation. You get minus 2x minus 9 is equal to 14 minus x minus 2x plus x minus x is equal to minus 9, 5. Therefore x equals minus 5. No, that's not the right answer. 14, 23. Yeah, so that's the left point and that's the right point, and so finally the answer to a question, the question is the inequality, and the modulus function is less than the straight line function, okay, and it is going to be minus 23 is less than x, which is less than 5 by 3. Alright, let's do another example. In this example you're going to do question number 13. Okay, in question number 13 they're asking us, okay, in question number 13 they're asking us to that we have the graph 6 minus x the whole we have the equation 6 minus x the whole modulus is equal to half x plus k. Okay, 6 minus x the whole modulus equals half x plus k, and this has got exactly one solution. Okay, one solution only. Okay, and we are asked to find the value of k and the solution to the equation. So let's start with drawing a graph. We have 6 minus x the whole modulus. 6 minus x the whole modulus is going to have y-intercept 6 and gradient 6 minus x is going to have y-intercept 6 and gradient minus 1. So we have this graph over here, and then the negative portion gets flipped, and so we have this graph. Now we have half x plus k. Notice that half x plus k, the y-intercept is, for the time being, the y-intercept could be anything. Okay, it could be here, it could be here, it could be here, it could be here. Okay, but the gradient is constant, it is going to be half. In other words, the gradient is going to be less steep than the gradient of these two parts. Okay, over here you have negative, that's obvious. Over here you have plus 1, this is going to be positive 1, but this is half. The gradient for this graph is going to be half, so you're going to have a less steep graph. So you could have either this thing, or you could have this thing, or you could have this thing, or you could have this and this. Okay, so now notice that if this graph, this equation has got only one solution, it needs to have only one point of intersection. So if from our scenarios over here, this graph is definitely not the answer, because it does not intersect the other graph. This is also not the answer. The very top over here is also not the answer, because it has got 2 points of intersection. This also has 2 points of intersection, therefore this is also not the answer. This over here is definitely the answer, because it is intersecting at just the vertex. Okay, it is just touching the vertex. Okay, and it does have only 1 point of intersection. Okay, so since this graph, this line over here with gradient half is touching this line in this graph at just 1 point, this is the graph that you need to find. Okay, so to continue finding an answer, notice that you can easily say the value 6 minus x the whole modulus, the value over here is 0. Okay, at this point the value of 6 minus x the whole modulus is 0. Okay, this graph also reaches 0, this graph starts from 0, so therefore at the point of intersection 0 is equal to half x plus k. At the point of intersection 0 is equal to half x plus k. Solve the equation. 0 is equal to half x plus k and x is equal to 6. Okay, so this entire point is 6, 0. Okay, so we have half into 6 plus k, and therefore k is equal to minus 3. Okay, and therefore and the value of k is equal to minus 3 is the answer to our first part of the question. Now the solution to our equation is x equals 3, x equals 6, excuse me, x equals 6. Okay, is the solution to our equation. We do not need to mention the y coordinate, okay, because the question does not ask us the graph. Okay, it does not have any y in it, so the graph was just for our solution we tried to use to help find a solution. So the final answer is going to be just x equals 6. There is going to be no y in the solution. Okay, again repeating what we did over here, we tried to draw the graph 6 minus x. We had half x plus k. Half x plus k, if it needs to have only one solution, it needs to touch the graph only once, or in other words, it is going to touch the vertex. Okay, at the vertex, x is 6, y is 0, x is 6, y is 0, and therefore substitute that into the equation. You can simplify to get k equals minus 3. Okay, and the final answer, the second part of the question is to just state the solution back, and that is x equals 6.